Hi friends, welcome back. Today we are going to solve Leetcode problem 429 N-ary tree level order traversal. So given an N-ary tree, return level order traversal of its nodes values. N-ary tree input serialization is represented in their level order traversal. Each group of children is separated by the null value. See examples below. So they have given us two examples. So let's just take this first example and we will discuss how we can implement this. So as you can see here, they have given us the node class, and the node class has it has a value integer, and every node will have list of nodes as their children. So as you can see, one will have a children 3, 2 and 4. So the number of children any node can have varies, so that's why it is a n-ary tree. In general binary tree, we only have left and right children, so only two children maximum. But this is a n-ary tree, so we can have many more children than two. So let's just take this example and let's just discuss over here. So we are actually going to solve this problem using like a level order traversal of a binary tree. So this is a not a binary tree, actually this is a n-ary tree because it has many more children. So but the concept is same, like the same concept we can use that we generally use for binary trees. So we are going to use a queue of nodes here. So let me just take this pen here. So we are going to use a queue of nodes, uh, and what we are going to do is, as we travels each level, we are going to put the children of that node in that level into the queue. So uh, for example, if we, let's say, every tree has a levels, so this is a first level of this tree. This one is second level of this tree, and this is the last level of the tree. uh, so this is the last level of the tree, as you can see. So here this element is 5. I think it's not visible, but yeah, that element is 5. It's just going in the back side. So what we are going to do is we are going to start level by level. So first we will start with the root, right? So we are starting at the root, so we will take 1 and we will insert this value into our queue. So this is our queue, and we insert 1 here. And we are going to, like, I'll show you the implementation at the same time when we are discussing the solution. So here we are going to get the root in the level order, and we are expected to return a list of integers. So I just defined a result of type list of integer that we are going to return at the end here. And First we will check if root is null, then we are just going to return that empty list, right? Because we don't have anything to return in that case. But here I defined the queue, it is just a new linked list, and we first offer a root to the queue, and then we will add that queue, that root's value, into the list of integer. Because for every level that we traverse, we will have a list of integers that we keep adding into this result, right? So that's how it will work. So after we added the root into the queue, then we will just iterate through the queue until it becomes empty, right? So all the way, like, we will iterate all the levels, all the nodes, and we will keep polling the nodes from the queue. So let me explain here. So first we actually added the root into the queue, so one. Then when we go to the next iteration into that while loop, then we will poll that one from the queue, and we already have list of 1 right here, so we will have only one element in the list because only one element for the level. So next we will get all the children of this one, right? 3, 2 and 4, that we will actually, when we poll the one, we will iterate through all its children and we gradually put those children into this queue. So we have like 3, then 2 and then 4, because we add these children into the queue, as you can see here. So here we get the queue size here, and then we are just looping like a for loop until I is 0, I is less than size I plus plus. So we will keep polling the nodes from the queue and we will get the children of that nodes. For each node there will be multiple children, and so we will get a list of nodes here, right? And we are going to again loop through all the children and we will keep adding into our list those children's values here, right? And at the same time we will be offering that uh, children into the queue. So as you can see, this once this for loop completes, then we will have the list for that level basically, right? So here you will see that as we traverse, now we are done with level 1, so we are done with this level. Now we are traversing and we are doing the next level, which is this 3 to 4. So we will keep polling element and we will keep appending this element into the queue, right? So we polled the element 3 here, we added into our list here, and at the same time we see this 5 and 6 as the children of 3, right? So we will keep adding this into the queue, right? So 5 and 6 we added. But when we start like for that level, we already know that we have to only poll 3 because we already got that size here, right? So first we get the size of the queue in the start of the iteration. So we polled 3, then we added the 5 and 6 children into the queue, then we polled 2 from the queue, then we added into our list, and we poll 4 and we added into our list. So that's how we have 3 to 4 list, as you can see here. So 1 is the first list, which is a sub list basically of the output, right? Then 3 to 4 is another list. So we are done now at this level 2, right? We are done now. So now we have this another level which is like 5 and 6, right? So we will now again define another list here for next level. So as you can see here, we always in this while loop, first thing we do is we create a brand new linked list, because we don't want to reuse the other list, right, that we had in the previous iteration. It should be a brand new list for every level. That's why we created list. So now again we will call first element 5. 5 does not have any children here, so as you can see 5 does not have any children, and 6 also does not have any children here, right? So we just add 5, then we poll 6, we don't have any children to add, and then we will just return that 5 6 here as the third sublist, right? So this is how we got this output by using a level order traversal of N-ary tree. So we used a queue of nodes, right? So queue of nodes we used here, as you can see, this is queue of nodes and this is just a new linked list, right? um, so that's pretty much it. I think I explained it in pretty details, that we go each level by level, we keep adding the element into the queue, and once we poll that element, then we will keep adding its children actually into the queue. So uh, and then we'll keep processing until we are done with all the children, right? So for example, let's just modify this example little bit for more things. So let's say if 2 has a more children, let's say it has a 2 children, let's say, right? 7 and 8 here. So 7 and 8 right here. So when we are processing this 2 here, then we now let's just consider this example from the beginning, right? So we processed a 1 first, which is the root. So we added this and we have this list as 1. Now we are again now processing this 3 2 and 4, right? So we added 3 here, then we added 2 because these are children of 1. So once we add this 2 here, then you will see that 2 has a 7 and 8 as a children, right? So for 3 we have 5 and 6 already added, so we have to add this 7 and 8 here, right? In that case 7 and 8, and then we will have 4 here, right? 4 does not have any children to add, Then in the next iteration, which is the third iteration, we will be processing this level, right, this whole level. So we will have it will like we will keep polling the elements. So we will have 5 here. 5 does not have any children, so we don't add anything in the queue. 6 here, 6 also does not have any children. Then we will add 7 and we will add 8 at the end. 7 and 8, they also don't have any children. So this is how it works actually. So I'm going to push this code into my GitHub repository and I'll give you the link so you can take a look into details. But we actually took, let's take the both examples that they gave us. So first one is the example that is there, and let's take this another example here, and let's just run these examples first. So yeah, so both our examples are passed. So let's quickly submit this solution. So the code got accepted. It runs 2 ms and it is like 85% on runtime. So I hope you like the solution of N-ary tree traversal, tree level order traversal using queue. So if you like the solution, please click on the like button and subscribe to my channel. I often keep posting the Leetcode problem solutions and Java J2E related interview materials. So if you are interested, please subscribe to the channel. Thanks for watching the video.